Hey Tops, today we are looking at uniform motion and we are going to be starting distance and displacement. So the first thing you need to know about motion is that it is relative, meaning it occurs over a certain amount of time and we have to measure it against some fixed point. So what I mean by that is motion includes a frame of reference. So in my frame of reference, I'm not moving right now because I'm sitting still in my seat. So if we talk about relative to the ground or relative to my chair, I'm not moving. Now, relative to, in the grand scheme of things, relative to maybe the sun, I am moving because we know that we are revolving around the sun, or Earth is rotating. So relative to a point in space, I would be moving at a particular speed. So an object is moving if its position is changing relative to another point. Think about it like if you're driving in the car. If you're just sitting there, you could maybe write, you could read, you could toss the ball up and down. It's like you're not really moving relative to the seat. However, if someone was outside of the car watching you go by, you're definitely moving. You're moving as fast as the car is going. So this is just a fun little GIF showing just how your velocities and how your speeds can be different. So, the velocity of the Milky Way through the universe is 230 kilometers per second, but a car driving on the road might be 100 kilometers per hour, but we're rotating too at 1,700 kilometers per hour, but we don't really feel that because everything is relative. So in physical science, when we talk about speed or velocity or displacement or distance, we're always talking generally about a point relative to the ground or relative to an observer. Okay, so this slide has a lot of information here, but we are interested in the definitions and the relationship between distance and displacement. So if you think about taking a trip somewhere, you might have to backtrack a little bit. You're going to have to change direction along the way. You're going to have to follow the sidewalk, no shortcuts. That total path length that you have to go, if we were to stretch it out, that is called your distance. Distance is the actual length of the path an object has to travel. And a distance is always positive, okay, meaning it has a positive value. It cannot be negative. You would never say, like if someone asked your distance, you wouldn't say, I went -5 kilometers. When you're talking about distance, we do not care about direction. Distance is called a scalar quantity, meaning direction doesn't matter. Okay, you'll probably learn later on about scalars and vectors, especially if you end up in physics. So a scalar is a quantity that can be fully described with only a number. So a scalar might be like temperature or volume or area. None of those values need a direction to fully describe it. However, when we talk about velocity, we really need to be interested in, well, what direction did you go to fully describe the motion? Or if we're talking about acceleration or force, well, which direction did you push that object? So when direction matters, that means it's a vector quantity. So those are some new terms, scalar and vector. You don't really have to fully understand them. Just know that a vector has to have direction. So let's continue our talk just on distance. So distance is the total path length, and it's a scalar, meaning it doesn't need direction. It can never be zero. And distance can be equal to or greater than the displacement. And we'll talk about that in just a moment. But again, distance is just if you were to stretch out the actual path. Now, before we read on, let's talk about displacement. Displacement is like your shortcut, okay? And displacement is a vector, so direction matters, meaning If we think about water displacement, when we did that in our volume lab, we just looked at the final reading of the water and the initial reading of the water. We wanted to know how much that object displaced the water. Well, that's what we're thinking about here with displacement. All I care about is start to finish. So the displacement of this object, I would have to, or this rider, I would have to measure the length from A to B, so from start to finish. And then I would also need to know a direction. So since displacement is considered a vector, I would measure that. Let's say it came out to be like 2 kilometers. I would say that's 2 kilometers, and then I could attach a direction with it. So that is south of east. If you wanted to be even pickier, you could measure that angle. Okay. So displacement can be positive and it can be negative. For example, when we think of movement, we think about movement across a number line. Okay. And so if you move to the right, that's considered a positive displacement. Or if you move up, like on a positive y-axis, then we would consider that a positive displacement. Anything to the left or moving down is considered a negative displacement. So those positives and negatives just indicate direction and only direction. Displacement could be 0. For example, if I were to stand up right now, run all the way around the room, and then end right where I started, my displacement would be 0. However, my distance, I would have to take a meter stick or something and measure the distance or the perimeter around my desk in order to find my distance. So distance and displacement can be very different. The only time distance and displacement are truly the same is when you're moving in a positive direction in a straight line. So anytime you're changing directions, your distance and displacement will be different. All right. For both of these, distance and displacement are both measured in meters, or that's the SI unit. You might see kilometers in a lot of the examples that we look at, or miles or feet. All of those are used to measure distance and displacement. So if you need to take a moment and pause the video and read through these definitions. Okay, because you're going to use this chart to create a Venn diagram. I want you to Venn diagram. I want you to notice things that are unique to distance and unique to displacement, but also how they are similar. Put that in the middle. So both of these simply describe how far something is traveling. All right, here is the definition laid out a little clearer. So distance is the total path length, and displacement we call change in position. Okay, so it's a final location, final position on think a XY number line, and minus the initial position. And so we use X for displacement because we think of something moving left and right along an X axis. So it'll have a final location and an initial location. So we're going to look through 3 examples, and then you're going to have a few to do on your own. All right, let's look at our first example. So an object moves from point A to point B. Okay, and then point B to point C, and then back to point B, and then to point C along the line. So maybe we dropped something and we turned around to go pick it up, and now we're on our way again. Okay, find the distance covered by the moving object. So the distance is going to be equal to the total length that this person traveled. So they went 5 kilometers, and then 4 kilometers, and then 4 kilometers again, and then 4 kilometers again. So they traveled a total of 17 kilometers, which is, I don't know where they're going. This isn't just walking down the hallway. They are on a trip. So maybe we're driving instead of walking. Now displacement is going to be a little different. So displacement is start and finish. So we started at 0 kilometers and we ended at, hold on, I need to fix something here. we ended at 9 kilometers. Oh no, there's a mistake right here. Okay, so we started at 0 and we ended here at 9. So my displacement is 9 kilometers. That needs to be fixed. So I hope you're listening and not just looking through this PowerPoint, but this should be 9 kilometers. I'll go back and fix that. Or, so if you could just look at displacement as start and finish, or you could look at displacement as adding up all the arrows. So when we're moving to the right, that's a positive displacement. So we go +5 plus a +4. And then anytime we move to the left, that's a negative displacement. So we're going to subtract 4 and then we add 4 back because we moved to the right again. So when we do 5 kilometers plus 4 minus 4 and then plus 4 again, we're back at 9 kilometers. So here the displacement is 9, whereas the distance is 17. So displacement and distance can be different. All right, what happens if you, oh no, I'm gonna have to stop this for a minute. Okay, so I cleared that up. What happens if you are changing direction? Then you need to remember that displacement is just start to finish, and we're going to solve that mathematically a little differently. So a car drives 5 miles east and 12 miles north. What is the total displacement? So we draw that out by going 5 in an east direction and 12 in a north direction. And then if you notice, this makes a right triangle. Okay. And when you have a right triangle, you use what's called Pythagorean's theorem to solve for the hypotenuse. Okay. We know that east and north make a right angle. So I know that I can use what we call Pythagorean's theorem, or we can say a squared plus b squared equals c squared. All right, where c represents our hypotenuse and a and b are the legs of the right triangle. So if we look at this one, we have 5 squared plus 12 squared equals our displacement squared. Notice how we change this hypotenuse to equal that displacement. So you keep simplifying. 5 squared is 25, 12 squared is 144. And that equals 169. And so your last step, which is important, we don't want to forget it, we have to get the displacement by itself. So to do that, we have to square root both sides, because remember, whatever we do to one side, we have to do to the other. So the square root of both of those will be 13. So my answer here would be 13 miles. And because it is a displacement, I need to attach a direction to that. So it would be 13 miles, and I could say northeast, north of east. Now, if I want to ask you to find distance for this one, we would say 5 miles plus 12 miles is 17 miles. Because remember, direction doesn't matter when we're talking about distance. Okay, our second example. Janaya walks 3 miles east and then 5 miles west. What's her distance and displacement? So when we look at that on a number line, 3 miles east is to the right, and then 5 miles from that point west. So the distance is going to be 3 plus 5, which is 8 miles. So that's the total amount that Janaya traveled. Displacement is a little different. Displacement, we could say 3 miles to the right minus 5 miles, because we went to the left, gets us -2 miles. Or we can look at it as your final position minus your initial position. So my final position was here at -2, and my initial position was 0. So displacement is going to be -2 minus 0, or we could just say -2 miles. All right, so your next video will be on speed and velocity. Let me know if you have any questions.